Hi, welcome to this session on redefining operational maturity in Kubernetes, leveraging machine learning and automation. My name is Brian Likasar. I lead our solution architecture group here at Stormforge, based in the US outside of Chicago. Real briefly about me, I've worked in open source about 25 years, started with Linux back on floppy disks in the 90s and all the way through today via places like Red Hat and Confluent, working on all sorts of different open source projects, Linux and automation with Ansible and Kubernetes, of course, and a lot of other things along the way. Been there, done that, as it were. I also love theme parks of all sorts, whether they're in Florida, California, or anywhere else. The regional ones are fun too. Enjoy them all, and I often take my family to these different places or my friends. Also wanted to point out on this slide real briefly, I like to perform mentorships. I like to help people out with their technology careers. I absolutely love what I do, and I love to help people find what they love in what they do. And if I can be of service in that way, please reach out to me on LinkedIn. Happy to connect and chat through that anytime on what amounts to any topic. Like I said, been there, done that. So maybe I can help you too. So the first thing I want to talk about is conventional configuration management processes. Now, the goal of these is to keep consistency across your environment, kind of phrased here as repeatability, while maintaining accuracy of what you want to accomplish and velocity while accomplishing that. That's what's important about configuration management. It's why we do it. It's really vital to systems of scale, especially those in Kubernetes, where you have a little complexity to add a bonus for you. And so as you think about this and you work through your environments, if any one of these three is not doing what you need it to do, if you're not meeting your velocity requirements, the business is frustrated with you, or your coworkers are frustrated, or your manager, or whoever it might be. And so we want to make sure that all of these elements are in, being handled well. And so the most common approach that people have is they use configuration as code, and indicated by the pipelines here on this slide. And that would be using something like, I think the phrase often used is GitOps, right? It's where you check in your configurations into a source code repository like Git, and then you have some sort of automated processes that will look at what you've put into this source code repository and then make those changes in your environment. And that applies from infrastructure all the way through your application configurations, any of the glue code, so to speak, or any of the elements where maybe you're defining things like data sources, destinations, environments like staging, development, production, whatever is most applicable to your world. That's where you're doing it. You're doing it configuration as code. And what's nice about this is that as anyone looks at it, it's kind of self-documenting to a degree. And in fact, there's some great tools out there that will take different things like Terraform manifests and render them as diagrams. So if you're more of a visual learner that needs to see the flow of things, it's a great way to determine that. So this has become a very common practice. And so with that in mind, let's look at what config as code means in maybe a Kubernetes environment. So with Kubernetes, we've got the config there at the top, right? And then it's coming to our Kubernetes environment. And the little looping arrow that you see there is just that a reminder that Kubernetes is declarative. And so when you say, I would like it to be as so, it will change what it is for you to see it that way. That feeds maybe metrics into our dashboards so that we can see what's going on, that we can see performance, these sorts of things. And there's a group of humans who are looking at those dashboards or maybe being alerted by those dashboards as things happen, as things occur in our environments. So what happens when something occurs? Well, what happens is that dashboard has been well configured and you know exactly what happened. It alerts the responsible team or teams, and then they go through a pretty quick review process of, well, here's what I need to change in an update process. Somebody else reviews it and would like to say, yes, that is a good fix for our environment. We will carry on that way. This will fix the issue, and it gets merged together, all the work, and it gets filed as a pull request. The pull request hits your repository, and then things are better. Well, okay. Hopefully you chuckled as I was saying that, because I was saying it in jest. That's not how I often see it play out. Let me talk more about how I often see it play out. So first, something's happened in the environment, and maybe it's not already set up in your dashboard to alert a human because you didn't have maybe some end-to-end transaction that has to go through in a certain period of time. And so users have complained of slowness, and they have notified your help desk, your service desk, whatever method they use. And that has happened, and you're just kind of stuck. You're like, well, we don't know who, so we're going to call an escalation and page everyone who it could be. I reach out to everyone. So everyone's getting alerted, everyone's joining these calls, and the teams who are responsible will quickly go to the dashboards. They'll probably end up creating their own custom views of metrics that they think are relevant to them. Everyone starts to kind of the phrase we use is check your backyard, right? I don't want to go yell at my neighbor and blame them if my yard is at fault. So we'll go ahead and do that, and we'll look around and we'll say, gosh, this is what's mine looks good. Mine looks good, and you're getting that data back out of the dashboards, and then ultimately everyone says, well, mine's fine, mine's fine. And so we play a board game instead of actually solving the problem for our users or for our company or for our leaders. And then if it was in what I see often, because I work with Kubernetes performance, what I see often is it tends to be viewed as we're not really sure what's going on here. So our answer is going to be to throw more resources at it. And in order to assign additional resources, your option is what we refer to lovingly as over provisioning. And so we use the meme here of over provision or over provision. Which way do you want to go? And of course, the management on that call who doesn't want to be on that call says, yes, sure, go ahead, over provision it. Doesn't matter to us. This is great. This will solve the problem, even though it's really more of a band-aid on a longer term real solution. And so now everything is fine. The problem of this, if you were to do a retrospective afterward, is that this was obviously reactive, manual, stressful, and time consuming. Really didn't solve the problem as quickly as the business dictates or as our users expected. And let's face it, just because that system became ready again, its dependent systems may take a while to notice that. You might uncover some other dependencies you didn't recognize when that part of the system was reacting slowly or poorly. This really gets out of hand fast and takes a lot longer to resolve than we'd like it to, frankly. So if we take that, along the way, and then somebody comes along and says, well, I see over the weekend that you increased the utilization here, and we've really got to talk about cloud costs here because our cloud costs are going out of control. And I used a meme. Hopefully you can follow it here. It is Lumberg from Office Space. Yeah, if you could go ahead and save us a few $1,000,000 on a cloud bill, that'd be great. But the reason I say that is there is somebody in your organization responsible for what all this costs. And they're probably frustrated and they're probably upset and they're probably wondering why this keeps happening because the pattern I just described is the easy path, not necessarily the long-term solution path. So is there a better way, or how can we incorporate some FinOps or financial thought around what we do with technology? And so if you're not familiar with it, the FinOps Lifecycle has three components to it. There's the inform step, which is about visibility and allocation. There's the optimize step, which is looking at your utilization and making sure everything is as efficient as it can be. And the operate step, which is how to continuously work on this. And so as you think about this with Kubernetes, what that really means is what do we fix? How do we fix it? And how do we operationalize it or continually fix it? And what I often think about here is because Kubernetes always runs at scale, you start small, maybe you have one namespace defined with your pods and you work with that. Before you know it, you've got deployments all over many namespaces and they number in the hundreds. And that's really great. You're utilizing your infrastructure, and I'm thrilled for you. I'm happy for you. And that's kind of the utopian state we wanted in the first place. But the downside of it is if you don't have some automated thought processes around how to continually investigate these things and then stop investigating them and have it automatically solving problems, you're going to just face a lot of churn. Mechanical Turk is the term that's used way too often. So can we balance what FinOps brings to the table and the principles that they follow and that they purport into the rest of what we just described? So let's look at that together. So with configuration as code, we talked about it before. We had that outline. I have the same exact chart here from before. I want to be looking at this with the original goals that we set out about accuracy, velocity, and repeatability with regards to bringing FinOps in. So again, let's be thoughtful about what this is costing us and how we're doing it. So earlier we had, again, humans come in and they said, increase these resources. Over provision was the joke, right? Over provision, over provision. So we said, okay, set those resources where we want them, or higher, maybe double them. Is probably, I hear that way too often. It's like 2 CPU, make it 4, 4 gigs of memory, make it 8. This is what we always hear. So those are the recommendations that kind of came out of the dashboard, or maybe you've been clever, you've faced this problem a lot, and you've created some measure of automation that is doing something very simplistic, like looking at the utilization the last time. Again, dashboards tend to be dynamic, right? And so the last update interval of the metrics from your environment, it said, okay, the utilization was actually here, but the amount of resources it requested was here. And so what I'll do is I'll maybe cut that in half. I'll maybe split the difference and average those together in an automated fashion. And you can even inject that into your dashboard. But let's talk about the accuracy of that. So in this case, in this example, the dotted line along the top is the requests. So in other words, we've set our request on this pod, as it were, to this value. And the usage is the line beneath. So anything shaded in that orange color there is waste. So we're 95% over provisioned, and there's a 5% performance risk. Now, the reason I articulate that as a performance risk is at that moment, what would really happen is if there was not, if you had your limit set there as well, I don't have limits on this slide, but there are limits there as well, you would be getting CPU throttled. So your application would stop, hit a plateau, and only be able to run at that level. So was that the right answer? Is that the right answer? Maybe. So then what some people might do is they might say, okay, well, I'm going to bump my requests up to handle the peaks. And so what they're doing in that case is they're looking back over time historically to see where it reached and set the request to that level so that no matter what, I will never have CPU throttling. If this were CPU, this could apply to memory as well. With memory, it's even more interesting because in that case, especially if you have limit set, you can have kills, out of memory kills, where Kubernetes just kills the pod. And by the way, for those of you who are relying on that ability to restart memory leaking applications, shame on you, I guess, if I can, but also please investigate that. Solve that problem at its cause instead of adding memory to it or relying on Kube to restart it. Like, that's the better way to do it. Anyway, I digress. Passionate about that topic. So another thought that you have is, okay, well, what if we reduce the requests to make it much closer to what the average is? I'm trying to get to the average here. So if I do that, am I not risking performance issues? Like at this point, especially during that spike, maybe that's the middle of your production day, maybe that's the logon period. What are you doing there? So the next thing to consider is velocity. How quickly are we making these changes? Well, if humans are involved, or even that crude automation I described is involved, it's going to take way too long for you to notice the problem. You're going to get notified by users, which is not the way we want to behave or act. And then from a repeatability perspective, can you quickly do it so that you can do this repeatedly, maybe throughout, like this time window could be over a course of a week, but it could even be over the course of a day. Can you as a human go in there and make these changes quickly enough, repeatable enough? And then again, think of that scale I was describing across hundreds of namespaces and applications. So what I propose that you do is this little chip here is to indicate machine learning. Leverage some sort of machine learning automation that can look at what utilization has been and look at its trends, its historical analysis. Maybe if it's trending up and to the right, we need to add more memory, or maybe notify someone there is a leak of some sort, and let it handle the resource related elements for you. So you can take that burden off of your application teams. You can stop escalating to teams over weekends and nights because it's just a low resource thing. And while you're getting yelled at about the costs, that's going to meet all three of the goals as far as accuracy, velocity, and repeatability. All of the information still ends up going into your configuration as code elements and into your dashboard. So you can still see it if you need to interrogate it. But now it cuts out the human element and the kind of mechanical Turk elements we were talking about before. So really kind of an ideal state for how to accomplish this. And if we were to recap the FinOps lifecycle, we're able to inform and see what's going on. We're going to keep our utilization at its most efficient. And we're going to continuously improve and operate this because it's all going to be automated. So that unconventional approach, maybe you're not doing something like this today, is going to get you all three of those at the max values, as high values as possible. And you're hopefully going to be able to sleep at night as well. So I've been Licko from Stormforge. Check us out if you're interested in any of those concepts. We do them every day, all day. Thanks a lot and enjoy PlatformCon.